Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about the elements on their classification. In the earlier sessions we have seen different earlier classifications and their drawbacks, and finally we have seen the modern classification of elements which was done by Mosley, and the categorization of elements in the periodic table and different namings we have seen. In this session, we are going to see a practice sheet related to the chapter. There is practice sheet 2, which includes different kinds of questions like multi-correct answer, comprehension passage, matrix matching, and so on. Okay, let us start the practice sheet. First, let us go through the multi-correct answer type questions. See the first one among those. Which of the following is or Dauberner's triads? What are Dauberner triads? Dauberner classified three elements as a set which are having similar chemical properties, and he arranged those three elements in the increasing order of their atomic masses, and then he observed the atomic mass of the middle element is equal to the arithmetic mean of the atomic masses of first and third element. In such a way, he arranged three elements as one set, and he called those elements as a triad. So in the honor of his name, they are called Dauberner's triads. Observe once in the given options which are triads of Dauberner. Chlorine, bromine, iodine is a set of Dauberner triad. Calcium, strontium, barium is also one of the Dauberner's triad. Lithium, sodium, potassium is also Dauberner triad. But carbon, nitrogen, oxygen is not a Dauberner triad. Okay, because these three elements are having different sets of chemical properties. This is not a Dauberner triad. The remaining three are correct. So correct answer will be now ABC. Okay, next one. Which of the following scientists have their contribution in classification of elements? Yes, we have studied about different earlier attempts for the classification. Of course, because of certain drawbacks, they were failed, but they are important. So see here the scientists who have their contribution in classification of elements. We have studied about Mendeleev's periodic table, which was the first periodic table given for the classification of elements, and even Newland also. Newland, how did he classify? He classified elements into octaves, isn't it? Dauberner classified elements into triads. He tried to classify the elements into triads. So in this way, these three scientists, they have their contribution towards the classification of elements. With Dalton, he has given his contribution in atomic theory, but not in classification of elements. Okay, so these three scientists, they're having their contribution towards the classification of elements. Now the correct answer is ABC. Next one, elements of the following pairs are against to Mendeleev's periodic law. What is Mendeleev's periodic law? First of all, when elements are arranged in the increasing order of their atomic masses, the properties of the elements are repeated periodically. So in the definition way, it can be said as the physical and chemical properties of the elements are periodic functions of their atomic masses. This is Mendeleev's periodic law. Means elements to be written or arranged in the increasing order of their atomic masses. In such a way, he arranged all the elements in his periodic table. But at certain pairs of elements, he did not follow this principle to avoid the confusion in the characteristics of the elements. So the element with the greater atomic mass was written before the element with the lower atomic mass, because that should be fit into the column with other elements with the similar properties. One of the examples is argon and potassium. So here actually argon has greater atomic mass than potassium, isn't it? Atomic mass of argon is 40, whereas that of potassium is 39. But according to its chemical properties, it is written first in the periodic table along with the other elements in that column like helium, neon, krypton, xenon, and radon. because it is also having same chemical property just like the remaining those. So that is why it is written first. So here he did not follow his principle or periodic law. Such kind of pairs of elements where Mendeleev's periodic law is failed to follow are called anomalous pairs of elements. One of those is argon and potassium. And the next, tellurium and iodine is also one more pair. And in the same way, cobalt and nickel. At these pairs of elements, he did not follow the periodic law. He arranged the element with the greater atomic weight first, followed by the element with the lower atomic weight. Okay, so these pairs of elements are called anomalous pairs in the Mendeleev's periodic table. Okay, these three A, C, D is correct answer. Next one, which of the following statements about the modern periodic table are incorrect? See the statements once. The elements are arranged on the basis of their decreasing atomic numbers. Is it true? No. According to modern periodic table, elements are arranged in the increasing order of their atomic mass, atomic numbers. But here they have given decreasing atomic numbers. It is a incorrect statement. The elements are arranged on the basis of their increasing atomic masses. Is it true? No. Because modern periodic table has taken the atomic number as a basic property of elements, but not atomic mass. It is also incorrect. Next one, isotopes are placed in adjoining groups in the periodic table. Is it true? No, because all the isotopes of an element are given the same position in the modern periodic table, but they are not given different positions. They all are given same position because modern periodic table is based upon the atomic number, and here the isotopes are the elements or atoms of an element with the same atomic number but different mass numbers. So as all the isotopes are having same atomic number, they are positioned in the same place in the modern periodic table. It is also incorrect statement. Next, the elements are arranged on the basis of their increasing atomic number. Yes, this is the only statement which is correct here. Elements are arranged in the increasing order of their atomic numbers. So remaining three are incorrect statements. They're asking to find here incorrect statements. So A, B, C is a correct answer here. Isn't it? Right, next one. Now let us say about comprehension passage type. Firstly, the passage given here. Classification enables a better understanding of not only the elements and their properties, but also the fundamental properties which govern them. Yes, this is made easy by classification of elements. Attempts were made to classify the elements according to one property or the other, isn't it? In the earlier classifications, atomic mass was taken as a basic property, and later in the modern periodic table, atomic number has been chosen as a basic property for the classification. Right, now let us see the questions based upon it. In Mendeleev's periodic table, elements having similar chemical properties or properties are placed in the vertical column. These vertical columns are called, what are they called? There are certain horizontal rows and vertical columns in the modern periodic, even Mendeleev's periodic table also. These vertical columns were called as groups, whereas the horizontal rows are called periods. Okay, vertical columns are called as groups. Next one, the horizontal rows present in the Mendeleev's periodic table. Yes, what are they called? Horizontal rows? Periods. Vertical columns are called groups. Horizontal rows are called periods. Not only in the Mendeleev's periodic table, the same it is given in the modern periodic table also. Which of the following is not a property of metals? Yes, based upon certain properties, elements are classified into metals, non-metals, metalloids, and noble gases. So metals are having certain particular chemical property or certain properties to them. What are those properties? Like ductility, malleability, luster. These all will come under the properties of metals, isn't it? But here if you observe, it is given non-conductivity. Are metals are non-conductors? No. Metals are good conductors of heat and electricity. They can pass electricity through them. All the metals are conductors of electricity. Of course, some are best conductors, some are somewhat least conductors. But anyhow, all the metals are conductors of electricity and heat. But here it is given non-conductivity as one of the properties of metals. So it is a incorrect property regarding metals. Okay. Next, let us go through matrix matching type. Observe the matching given here. In the column 1, the scientists who contributed towards the classification of elements, their names are given. In the column 2, their classification, in which way they have elements were classified, both those scientists are given in the column 2. Try to match the scientist with his classification. First, if you see Newland, how did he classify elements? Newland classified elements into octaves, means set of 8 elements. When elements are written in the increasing order of their atomic masses by Newland, he observed the properties of one element in that series are being resembling with the consecutive 8th element in that series. So he called this set of 8 elements as one octave. So they are called Newland's octaves. Okay. Next, if you see, or the next one, Lavoisier. So Lavoisier, before these all classifications, he classified elements into two categories. They are metals and non-metals. Elements were classified into metals and non-metals by Antony Lavoisier. Next, Mendeleev. How did he classify elements? Mendeleev classified all the available elements into a tabular column. So the first periodic table was given by Mendeleev. That's why you say the father of periodic table was Mendeleev, Dmitry Mendeleev. And we can say he was the scientist who succeeded to classify all the available elements into different groups and periods. He could fit all the available elements at the time into the periodic table. So periodic table was given by Mendeleev. Next, Dauvergne. How did he classify elements? Dauvergne classified three elements as one set which are having similar chemical properties. So these three set of elements are called triads. In the honor of his name, they are called Dauvernier's triads. So Dauvergne classified elements into triads. This is the matching. Observe once: Newland octaves, Lavoisier metals and non-metals, Mendeleev periodic table, and Dauvergne triads. Okay. Next, one more matching is given here. Certain groups of elements are mentioned in the column 1. In the column 2, there is special names. Based upon certain characteristics, they are given certain special names. So match these group of elements with their special names. See the first one, 1A group elements. What are they called? First A group elements are called alkali metals, isn't it? Because these first A group elements form bases which are soluble into water. The bases which are soluble into water are called alkalis. So these metals are forming alkalis. So these first A group elements are called alkali metals. Okay. Next, second A group elements. What are they called? Second A group elements. These second A group elements also form alkali solutions. So these are also called alkali metals, and even they are all available from the earth crust. So based upon these two characters, second A group elements are called alkaline earth metals. Okay, second A group elements are called alkaline earth metals. Next, third one, seventh A group elements. What are the seventh A group elements? Fluorine, chlorine, bromine, iodine, and astatine. These elements are specially called halogens. So the meaning of this word halogens is salt formers. We know most of the metallic salts are in the form of either fluorides or chlorides or iodides. So based upon this reason, these 7th A group elements are called salt formers or halogens. So the common name for these 7th A group elements is halogens. Next, 8th A group elements. What are elements present in the 8th A group or 18th group of the modern periodic table? They are helium, neon, argon, krypton, xenon and radon. We know these elements are least reactive or highly stable elements. They do not participate in the chemical reactions at all. They don't participate in the chemical reactions with other elements and even themselves also. That is why these elements are specially called noble gases or ideal gases, and even they exist in the very rare quantity in the atmosphere. That's why they're also called rare gases. See here. So 8A group elements are called rare gases and noble gases also. This is the matching. Observe once again. First group elements. What are the first group elements? Here you have to remember one thing. Hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. These are first A group elements. Out of these, except hydrogen, remaining elements are called as alkali metals. We have to remember this. Even though hydrogen is present along with these elements in the first group, hydrogen is a non-metal. It won't be considered as alkali metal. Okay, except that remaining elements are called alkali metals. Next, second A group elements. What are those? Beryllium, magnesium, calcium, strontium, barium and radium. These elements are called alkaline earth metals. Next, seventh A group or 17th group elements. Fluorine, chlorine, bromine, iodine, acetylene. These are called halogens, which means salt formers. 8th A group elements: helium, neon, argon, krypton, xenon and radon. These are called noble gases, rare gases or ideal gases. And this group contains completely all gaseous elements. Because of this, they are also called as aerogens. Okay, there is one matching. Next, let us see about statement type questions. See the first statement given. Mendeleev classified elements based on atomic masses of the elements. Isn't it? Yes, this is true. Mendeleev classified elements based upon the atomic masses of the elements. Statement 2. Mendeleev's periodic table has 7 groups and 8 periods. No, 8 periods and 8 groups and 7 periods. It is given the reverse way. This is incorrect. Only first statement is true, second statement is incorrect. Where it is? Here. See. Okay, next one. See the first statement. Alkali metals having the largest atomic volumes occupy maxima of the curve. Yes, in the curve given between atomic masses and volumes, alkali metals are having greater volumes. So they are occupying maxima in the curve. This is correct. Luther-Meyer curve represents the atomic volume versus atomic masses of the elements. In that it is observed the peaks of the curves are occupied by alkali metals. From that we can say alkali metals are having greater volumes. Right? The atoms are bigger in size. This is true. The transition metals occupy the maxima of the curve. This is incorrect. Maxima of the curve was occupied by alkali metals but not transition metals. Okay, statement 1 is true, statement 2 is incorrect. Again here the C. Okay, next. So the statement 1. The elements in the modern periodic table are arranged on the basis of their decreasing atomic numbers. Is it true? No. In the modern periodic table, elements are arranged in the increasing order of their atomic numbers but not decreasing order. Right? What is statement 2 given? The elements in the modern periodic table are arranged on the basis of their increasing atomic masses. Is it true? No. In the increasing order of their atomic numbers they are arranged, but not on the atomic masses. So, according to modern periodic table, these two statements are incorrect. Where it is, both the statements are incorrect. Next, let us see analytical approach type questions. See the first one among those. The elements which exhibit both vertical and horizontal similarities. What are those? Rare earth elements. Because the rare earth elements nothing but lanthanoids. These elements all they belong to around 15 elements are there including lanthanum. These all elements belong to same group and same period. They belong to third B group, that is third column, and they belong to sixth period also. All the elements will come under same group and same period. So they exhibit similar properties because of the similar sizes. So they are rare earth elements. Next, the atomic number of an element is 16. Predict the nature of the element. How can we predict the nature of the element based upon the atomic number? If we write the electronic configuration of that element, if it is having 1 or 2 or 3 electrons in the valence shell, we can predict it as a metal. If it is having 4 or more than 4 electrons, it comes under a non-metal. And if it is having exactly 8 electrons in the outermost shell, then it is considered as noble gas or ideal gas. Let us write the electronic configuration for this 16 first. How do we write? 2, 8, and next what we get in third shell? 6. So for this element, there are 6 electrons in its valence shell. As it has more than 4 electrons in its valence shell, it is a non-metallic element. What is that element actually here? Element with atomic number 16 is sulfur, isn't it? So sulfur is a non-metal. It is present in the 6th A group or 16th group of the modern periodic table. Along with oxygen, we say the group elements as oxygen, sulfur, selenium, tellurium and polonium. These all elements are generally non-metals, as it is having 6 valence electrons. It is a non-metal. Next, considering the chemical properties, atomic weight of beryllium corrected based upon equivalent weight. Okay, based upon the equivalent weight, the atomic mass of beryllium is corrected by Mendeleev. Okay, next, the position of coinage metals in the Mendeleev's periodic table is. What are coinage metals means? Coinage metals means copper, silver, gold. These elements were used for minting coins in the earlier days. That is why these elements, copper, silver, gold, are called coinage metals. These elements are present in 1B group of Mendeleev's periodic table. 1B group. Okay. Even in the modern periodic table also they present in the 1B group only. That we say as a 11th column or 11th group of the periodic table. Okay. Coinage metals are present in the Mendeleev's periodic table in 1B group. Coinage metals are copper, silver and gold. Why they are called so means they were used for minting coins in the earlier days. Okay. Next, what are the indefinite positions of hydrogen element present in the Mendeleev's periodic table? So based upon its chemical properties, hydrogen was given 2 positions in the Mendeleev's periodic table. We can say as it is also one of the limitations or drawback of the Mendeleev's periodic table, isn't it? So because of its properties, which are coinciding with the alkali metals as well as halogens. So hydrogen is positioned in 2 places in the Mendeleev's periodic table. What are those 2 places? One it is 1A along with the alkali metals. Those are lithium, sodium, potassium, rubidium, cesium and francium. Along with those, the top position is given for hydrogen because it is exhibiting certain properties similar to these elements. And along with the halogens also one more place is given for hydrogen. Halogens means fluorine, chlorine, bromine, iodine and astatine. It is exhibiting certain properties which are similar to that of these halogens. So these elements are present in the 7th A group. Okay, hydrogen is given two positions, one in the 1A group and one more in the 7th A group elements. So this is the correct answer. I think it is not given here. Okay, that's about practice sheet 2. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today and visit our website aimstoday.in for latest updates and recorded videos.